Hello everyone, my name is Jordan and this is an overview of my major project, Product Quality Modeling Simulation for AMC. This project aims to create a prototype and data framework for the AMC artificial intelligence cases. Within the AMC setup, PLC and various smart devices are used to generate data during operation. Such operation technology data is then collected by the Kepware platform and is transferred over to Thingworx for further analytics. I am now going to show you a simulation for this data flow. I'm using a Raspberry Pi to represent an OT side edge device that will generate the data for analytics. The view that I'm sharing here is the desktop UI view of the Raspberry Pi. An OPC UA server is coded within this Raspberry Pi in Python such that random data are generated and are wrapped up using the OPC UA protocol. By using Kepware, a middleware application that is configured with the OPC UA client connectivity, Kepware is then able to connect to the Raspberry Pi OPC UA server to stream in the live data for consumption through the OPC TCP address. The live data can then be seen here through the quick client. Passing data from Kepware to Thingworx is also very straightforward. Just with a few configurations from Kepware, I am able to connect and pass data to the Thingworx platform now. All this data which was transferred from the Raspberry Pi can now be seen here and is represented by this data model inside Thingworx. What you currently see now is the product quality modeling dashboard created using Thingworx as well. The functionalities of this dashboard fully depends on a previewed AI model that is built by using Thingworx Analytics and the simulated data. The model can be seen here inside Thingworx Analytics. In the future, upon collection of real production data from AMC, I can then pump in the real data and rebuild the model such that this prototype can then immediately be used in production. This dashboard shows how product quality modeling will be helpful for the AMC acrylic panel production. This acrylic panel product will go through drilling and inspection process. The first section here shows real-time machine data that are collected for quality models such as the vibration rate in the production line, the drilling station cylinder actuation time, the electrical consumption, as well as the drilling speed. Production and quality engineer can check the predicted quality that is based on the real-time production data and can then immediately be notified of any unacceptable quality before the whole batch of drilling completes. They can then take actions in very early stages. In this case, the quality model can then help to greatly reduce the wastage of raw materials and boost the overall quality rate. The computer's vision inspection system data is streamed in here to calculate the real quality of the product. Both this actual quality and predicted quality are plotted in the same graph here, so that data scientists can refer to it to validate their model accuracy. Should any serious deviation happen between the actual and predicted quality rate, an alert will then be sent to the data scientists for them to revalidate or update the model. As for this historical data section, it helps production engineer or quality engineer to zoom into the historical machine data level so as to check for any trending data or to help them with the root cause analysis. For the predictive quality section, it allows enterprise level to carry out what-if scenario analysis. For example, if the vibration rate can be improved to a certain level with the installation of a stabilizer, what would be the relevant quality improvement that can be achieved? From this prediction, enterprise levels can then make a data-driven decision as to whether or not such investment will have good returns. As for this prescriptive quality section, this section will allow user to select one or more combination of fields in which they can optimize for better quality. The prescription result will intelligently reveal the best parameter value that users can potentially bring in order to maximize the acrylic panel product quality. Lastly, for the quality alerts and recommendations section, stakeholder will be notified of any poor quality alert should the quality fall into an unacceptable range or if they have the tendency to fall into such range. Feature weightages which causes such alert will then be quantified and listed to help the quality engineer locate the key issue immediately. This is all for my presentation on this AMC quality model simulation and use case explanation. Thank you so much for listening.